Okay, now let's continue with this our discussion with the median filter. So for this one, I will like to ask you to open this file, which is smooth versus median.m, and you also required dusty.bmp here, okay, to run this one. Okay, for this one, okay, if you see, or if you check the code in this m file, actually there's two things that actually the purpose of this coding is we want to compare between the output after enhanced with the median filter as well as averaging filter if the image is affected with sus and paper noise. However, if you see in the code there, we don't have any example image that affected with sus and paper noise. That's why we just, in order for you to to simulate that situation, one thing you can do is that you can use this function. Okay, this function is actually, the purpose of this function is to add some artificial noise into your image. Okay, don't get confused with that, because since we don't have the practical image where our image is affected with such and paper noise, so that's why one way we want to simulate this situation, you can actually take any image, clean image that you want, and then you can add the sus and paper noise, or in other words, this function is actually add an artificial sus and paper noise into your image. Okay, so if you run from here to here, I just stop the code here, so now it will execute from here to here. So if I run the code there, now you can see that actually this is our original image. Okay, this is our original image. Okay, this one, and this one, and this one is our image that we add some artificial sus and paper noise, and we put there, we set 0.03, that is represent the density of the noise inside this image. Okay, if you put small, then you can see the dot is not so much inside the image. Okay, so then after that, once you get this image, okay, now we assume this is the input of the process, because the situation is we don't have this kind of image that affected with sus and paper noise. So that's why we take some clean image, we add some artificial sus and paper noise, so we can do some simulations there. Okay, assume this is the input of the next process. So now in order for you to apply median filter, this is the function that you need. Okay, then you need to key in the input of the input image here, and then the size of the median filter, either you are using 3x3 or 5x5, you can type it beside that. Okay, you can type in, if you want to use 3x3, you can type this in this way. Okay, or you can, if you want to use 5x5, you can type in this way. However, if you don't type at all, actually by default it's assumed that you want to use a 3x3. Okay, now we are using 3x3. so if you run this code, okay, line by line, okay, I just click here to step down, and then I display the output G there. Okay, that is the output. This is the output of the image. Okay, remember this is the original, the one that we add artificial sus and paper noise, and then we try to remove this noise by using sus and by using a median filter. Okay, now the next process is just, we want, instead of using the median filter, we also try with the average filter, just want to compare the output between the median filter and average filter. So if I try to stop this coding, I want to execute the whole code. Okay, let me delete this one back. If I try to run the whole code, okay, then you can see there, okay, this is you can see here, okay, this is the original image, this is the image affected with artificial sus and paper noise. This one is output after median filter. This one is output after median filter. So you can see that even the smoothing operation or averaging filter cannot, it's not better, it's not good as compared to median filter. But in terms of reducing the strength of this noise, actually the smoothing filter or the averaging filter is done that, meaning that is why we can consider that if you don't have any median filter, then one alternative way you can do in order for you to tackle sus and paper noise, one of the suitable approach is by using a smoothing operation, because smoothing operation as well, it also reduce the strength of the sus and paper noise. Okay, even though you can see this, there's still remaining sus and paper dot there, but the strength have been reduced as compared to the original image, which is this one, the input image, which is the one. Okay, but however, of course, it cannot reduce the strength to zero or to close to zero as compared to if you apply the median filter, because the median filter now is almost clean. Okay, it's almost clean. Okay, that is why we try to see the comparison there. Okay, that is there's a two point that where the median filter is have some advantage as compared to the average filter, because the average filter, one, it's managed to reduce the strength of the sus and paper noise, but it's not removing the noise at all. Okay, as then we can consider smoothing filter as well can enhance the image in terms of reducing the strength of the noise. However, one thing that another thing that we want to highlight is that that make the median filter more advantage, or more give some advantage, more better than average filter, is that the median filter, okay, after removing the noise, is also remain the sharpness of the image, while the smoothing filter or the average filter, okay, provide some blurring effect to the image. So that is one of the disadvantage of average filter, which is cannot be compared with median filter, because median filter work better for that kind of situation. So that's why if you talk about sus and paper noise, median filter work better than smoothing filter in tackle this kind of noise. Okay, another things that I would like to highlight in this simulation is that one thing that you can try is that, okay, median filter is good at removing sus and paper noise for this situation if the sus and paper noise, the white dot and the black dot is in size of a single pixel or a pixels, okay, in size of 1 pixels. But let's try some sus and paper noise with high density than this. Okay, so in order for you to run that simulation, okay, you can increase this value. Let's say I want to use 0.2 for example. Okay, if you want to try to run this one with sus and paper noise with density of 0.2 instead of 0.03, which is larger than before, so you can see what happens there. So when we set the sus and paper noise with high density, which is 0.2, so this is the example of image affected with sus and paper noise with high density. Okay, as you can see that this is the output after applying the median filter, and this one is output after applying average filter. So as you can see there, even most of the sus and paper noise managed to be removed by the median filter, but you can still see the remaining a few white dot and black dot. Okay, this is because when the density is higher, then the black dot and the white dot inside this image is become more and more bigger. It's not 1 pixel anymore, it can be more than 1 pixel. So in other words, by depending on median filter with the 3x3 that we have discussed before, okay, if you remember the previous video lecture when we discussed about median filter, okay, in order for removing the white dot and black dot, we need to perform the set of pixel into ascending order, and then most of the time the black dot or the paper noise is always going to the most left, and then the sud noise, which is the white dot, is going to the most right. Okay, and then that's why median filter always choose the median value or the center value. But if you imagine, if the white dot and the black dot is become more and more bigger, so when you sort it in the ascending order, if you talk about 3x3, which is 9 numbers only, 9 item only, now doesn't matter is it white dot or black dot, now it will extend or it will occupy as well at the center, because when the size it become big, the number of pixel the number of pixel that belong to noise, doesn't matter is it white dot or black dot, become larger, or become the number of pixels become higher that represent the white dot and black dot. So when you sort that in the ascending order, of course the noise now is already occupied as well at the center. Okay, it doesn't matter is it a black dot. Okay, if we talk about big black dot, then it will occupy at the center. Okay, and if you talk about the white dot, it's also occupied at the center when the number of pixel become number of pixels that represent noise become bigger and bigger in that set of 3x3 window size. So that's why now the 3x3 median filter is not relevant anymore, because when you choose the center value, now the center value as well as the center value is occupied as well by the noise. Okay, so that's one of the alternative way you can, or one of the things that you can do to solve this problem is by increasing the size. Instead of using a 3x3 median filter, you can use 5x5, 7x5, 7x7. Okay, by having a larger window, now you make sure that the most left that belong to the noise, or the most right that belong to the noise will be extended far more to the left or far more to the right, so the center is not occupied by any noise that come from the left or from the right. Okay, so that's why we can increase the size of the filter if you are talking about a median filter. Okay, and then later in the chapter 5 we will talk about what we call as a adaptive median filter. That is actually a median filter that have a capable to changing the size of the window, okay, according to the situation, which is better in solving this one, because it will automatically changing the window size when they want, because it's depend on the situation. But this one, the disadvantage, like I mentioned previously, because we don't know the density of the salt and pepper noise. But if the salt and pepper noise have a high density, then you need to manually set your window your median filter with higher window size.